In this question, we have a function, and we are told that the domain is all real numbers except that x is greater or equal to 3. So this is a restricted domain rather than the natural domain. And hence, if we're finding the range, it's going to be a restricted range as well. But if we just ignore this x greater or equal to 3 for a moment and just sketch or kind of think about this function, we can get an idea of where the turning point is for the quadratic. So I'm going to complete the square. That's a standard, like, quick way of being able to find the turning point, the coordinates. So it's going to be x minus 2 squared minus 4 plus 9, which is x minus 2 squared plus 5. And that means if I sketch this graph, I'm going to get a minimum at 2, 5. So say like here. And then it's going to sort of look like that. I didn't quite hit the minimum, did I? So I'll just move it down. Now, we've got to, so we can see that it's going to be like y is greater than or equal to 5, except now we do need to bring this in, x greater or equal to 3. What we can see is that's going to be here. And so the function is in fact just going to be this purple bit. And what I can do is, okay, I'm still in part A, so when x equals 3, f of x will equal, I can actually use the completed square form. It's just going to be 1 squared, or 1 plus 5 is going to be 6. And therefore, overall, the range is going to be f of x is greater or equal to 6. So the key thing is that, get your turning point as normal. Like, understand, because it could have been that the turning point was somewhere else. I don't know. I'm not sure exactly how it would work, but you know, get the turning point, then figure out where x equals 3 is and get the range from there. On to part B, where we have this function g of x. And we're asked for an expression for g of f of x. So g of f of x is actually g of f of x in brackets like that. So it's going to be g of x squared minus 4x plus 9. And so I can take my g of x and I can simply replace my x's by this thing here. And of course, I'm adding 1 as well. Now, often when you define a function, you should also define the domain, but actually that's been asked for in part C, so we can leave it like this for now. And you can see there's only 1 mark. So this last part is to find the domain and range of g of f of x. Now, here's what we've got to remember. We're starting with x, and we are putting it into this function f of x to start with, and then we are putting it into g of x, which gives us y. That is what is happening. But we were told right at the start of the question that for f of x, x is greater or equal to 3. So that is also the domain of this function. It's going to be that x is any real number, that x has to be greater or equal to 3. Now, we will find the range. Well, we actually already have the range of f of x because that's what we did in part A. So it's going to be that f of x is a real number. Technically, I don't really need to write that. And then f of x is going to be greater or equal to 6. And so that becomes the domain of what we put into g of x. I don't really need to worry about what is going on here. I can, in fact, just look at g of x is equal to 10 divided by x plus 1. And I think a good idea is to sketch this, think about what is happening. So it's going to be a bit like 1 over x, but it's going to be a translation by minus 1 in the x direction. So I can put an asymptote in. And then the 10 is just going to stretch it, so it's not really going to affect it too much. And it's going to look like this. Therefore, if I'm looking at f of x is greater or equal to 6, it's going to actually be this part of the function here. So when x equals 6, g of x is equal to 10 over 7. And that's going to be the maximum value, in fact. And then as x tends to infinity, g of x will tend to 0, but it will never actually equal 0. So overall, for g of f of x, I wrote this already, but I'm going to write it again. X is any real number, but x must be greater or equal to 3. And then it must be that g of f of x is greater than 0, but it is less than or equal to 10 over 7. So the main takeaway message really is that when you have a composite function, the domain is going to be the domain of like the first function that you find. And then the domain of the second function, I mean, you might be composing more than two, but the second function, the g of whatever, well, the domain of that is the range of your first function. So you have to work it out really carefully. I know when I'm teaching this topic, I can be a bit guilty and not go into a lot of detail on this because there's so much going on anyway. We're trying to cover the topic, talk about composite functions and inverses and domain and range. But yeah, that's why trying these questions is really important, and I hope you're happy with it now.